So this is lecture 10 of laws of motion, physics class 11. So today we will be talking about the topics of frame of reference. So frame of reference is when we are talking about frame of reference, it is the platform used to observe a body. So we are calculating the acceleration, velocity, displacement, etc. The movement of the body from the point of view of an observer, right? So observer, when he or she is standing in a particular particular position, that we take it from the frame of reference. So, for example, usually the frame of reference that we deal with is that of the Earth. So, mostly observer will be standing on the floor or on ground, that is Earth, and then some object will be moving, so that object is also placed in on the floor. That is what we talk about, right? It's an object is placed on a smooth surface and it is rolling or it is translating. So that is what we have discussed all this time. So the this is so the frame of reference. There are two types of frames of reference. One is inertial frame of reference, and another one is non-inertial frame of reference. So, what is the difference between inertial and non-inertial? Inertial frame of reference is where the frame of reference is not moving. Okay, it's not moving. That is, not moving means there is no displacement, so there is no velocity, there is no acceleration. Actually speaking, we are talking about acceleration here. It can move with a constant velocity also. Still the frame of reference, we take it as uh, an inertial frame of reference. But the acceleration of that frame of reference should be zero. That is what we talk about when it comes to inertial frame of reference. When it is non-inertial frame of reference, the frame of reference is accelerating. So acceleration of the non-inertial frame of reference is not equal to zero. It will have a non-zero acceleration. Okay. So you can see this picture here where a girl A is standing on a moving platform. This is having an acceleration of A towards the right side, and you are the observer. You are standing here on ground, which is like ground in means there is no acceleration over here. So for this girl, if this B was standing inside here on this frame of reference, if B was standing, then this girl appears to be stationary to this observer, right? Why? Because when he is looking, there is no change in displacement or velocity with respect to this observer. So for this person B, this A will be at rest. But for this person B outside, what is happening is when he looks at this person A, she is moving towards right with an acceleration of A. Okay, so this is something which we also observe in our day to day life, right? Like we are standing at the bus stop, and the bus will be moving with an acceleration of A, and for us, the passengers inside the bus is um, is moving with an acceleration of A. But for a person who is sitting inside the bus, their co-passengers are if they are also sitting in inside the bus, then for them these co-passengers appear to be stationary, right? So another important concept in this frame of reference is pseudo force. Pseudo force is something that is that we consider when we are in non-inertial frame. So why the pseudo force is important? Non-inertial frame of reference. Okay. So what is pseudo force? Pseudo means false. Okay, false force. So why it is called this pseudo force? Let's deal with that first. So according to Newton's first law, we know that there won't be a change in motion, a change in the state of uniform rest or motion, unless and until an external force is acting on that object. Right. So, why, when the observer is standing on the floor and observing a passenger inside the bus, that person is moving with an acceleration of A. And when this observer get inside the bus and observe this passenger, then suddenly that acceleration is zero for that co-passenger. So how that is happening? So from the motion of that person to the state of rest, some kind of change has happened. So that change will happen only if an external force is acting. So that force we will be we will be saying as pseudo force. So I'll explain it once again. So this is that bus. Okay. So this is that bus. This is moving on this road with an acceleration A, and there is this person who's standing inside the bus. Okay. And this is the observer. Okay. So this is observer. Observer is standing inside the bus and observing this passenger. Okay. This passenger. Hmm? Now, the same observer, there is this another observer. So this is observer 2. This is observer 1. He, he or she is standing on the ground and observing this passenger. Uh, okay. So what is happening is this, is an inertial frame. Why? Because this platform is not moving or accelerating. So this is an inertial frame. Let me correct one misconception. If the platform is moving with constant velocity, then also we consider that as inertial frame. Okay. Only when a platform is not uh, like platform, when it accelerates, only then we will call it as a non-inertial frame. Okay. If the platform is moving with a constant velocity or is at rest, then that is an inertial frame. Okay. So this this person standing here is at an inertial is on an inertial frame, and inertial frame of reference, and this observer is in a non-inertial frame of reference. Okay. So wherever we are observing this person, this passenger, it should come. It should be the passenger's movement should be analyzed in the same manner, right? So why we are not able to analyze that in the same manner? So for this observer one, this passenger is accelerating with an acceleration of A, and for observer two, this passenger is at rest. So from this acceleration, the movement with an acceleration A to this passenger being at rest, there is some kind of forces on play. For example, for this observer, when he is observing this observer 2, when this observer 2 is observing passenger 1, when if he or she is perceiving this passenger to be at rest, that means that external force of A is counter balanced by an external force, which is why this person is seeing this passenger to be at rest. So, what is that external force which is counter acting on this passenger? That is what is called as pseudo force. Okay, so pseudo force is what makes this observer to believe that uh, believe that the is passenger is at rest. Okay. So, what is the pseudo force? Pseudo force is something which is acting on a non inertial frame, which will uh, change the perception of the observer inside that platform uh, in a way that they cannot perceive the movement of the frame. Okay, so this observer too is not perceiving the movement of the platform because of this pseudo force that is acting. Okay, so how to calculate the magnitude and direction of this pseudo force? So magnitude and direction of pseudo force. So how to calculate that? The magnitude is very easy. So what I have told us, this passenger is moving with an acceleration a, right? So let's consider the mass of this passenger is m and acceleration is a. So the force of this force at which this passenger is moving is m times a, right? So mass of the passenger m times a, that is mass of the object, mass of object or passenger times the, okay, I'll write it with a different color. Um, mass of object, mass of object or passenger times acceleration of frame, the frame of reference. So that is how you calculate the uh, uh, this for observer one. I'm talking about this force. Okay, so for observer one, this passenger has got a force acting on him or her, which is accelerating that person with an acceleration of a. Okay, so this force F is something which we feel like which the observer one thinks, which is accelerating this passenger at an acceleration of a. Okay, now for observer 2, this passenger is at rest, right? So for observer 2, this passenger is at rest. So the mass times acceleration is 0. So for observer 2, what is happening? This FOB1 of the force which is understood by observer 1 is counterbalanced by a pseudo force. Okay. So this counterbalancing of pseudo force means what? So that is equal to 0. FOB2 is 0. That means FOB1 minus F pseudo equal to 0. That means FOB1 equal to F pseudo. So what was FOB1? FOB1 was mass times acceleration. That is mass of the object times mass of the object or passenger times acceleration of frame of reference. Right. So that is what is F pseudo. So what is F pseudo? The magnitude of pseudo force is what? Mass of the object. The magnitude of F pseudo is mass of object times acceleration of frame of reference. Okay. So that is how we calculate the magnitude of pseudo force. Now, direction is what? Direction is we were telling about pseudo force is what? Pseudo force is the force which counterbalances or which acts, which opposes the acceleration of the frame of reference. Like the for the observer inside the non-inertial frame of reference, this force which is acting on the frame of reference is being counterbalanced by the pseudo force. So that means it is opposite to the direction of acceleration. So if pseudo is acting opposite to the direction of acceleration of frame of reference. Okay. So this is a very important concept because we will be solving problem with this concept now. So the direction and accelerate. So the direction and magnitude you should know to how to calculate that. Okay. Mm, Now we will talk about weighing machines. Okay. So what does weighing machine do? So we first, the primary concept of weighing machine is whether that uh, calculates or whether that gives a value of mass or weight. Okay. So weighing machine, what it is giving us the weight of an object, not the mass of an object. For example, for a person on Earth, uh, the mass equal to 6 kg, weighing machine will show what approximately 60 kg, or it is like the actual value is what 6 times 9.8 Newton. Okay, this much Newton. Okay, 6 kg times 9.8 meter per second square. That is what the value of the person on this weighing machine. Okay, so that gives what? The weight of the person. Second, how does it give the weight of the person? For example, this person on earth will exert mg force on this weighing machine, right? This mg force, because of this, there will be a normal force on this weighing machine, and this person will also experience a normal force given by this weighing machine, right? So what what is being calculated here? The normal force on this weighing machine. This normal force is what is being shown by this weighing machine. The FBD of the man will look something like this. The FBD of man is like this is the person. So mg is acting downwards, n is acting upwards. Okay, so that is counterbalance because this person is at rest, right? When you are standing on a weighing machine, this person is at rest. It's not he is not moving up or going downwards. So that's why n equal to mg, because if he is at rest, then that force equal to 0, so n equal to mg. So this n is the same n over here. So for FBD of weighing machine, what will happen? FBD of weighing machine, this weighing machine is here and it will have a n over here. So that n equal to mg that we have found already. So that's why this normal reaction, whatever is being shown, whatever is shown on the weighing machine is equal to the weight of the person. Because what we have understood is weighing machine is something which shows the normal reaction that is on the uh, surface of the weighing machine. Okay. Since the normal reaction is equal to mg, that is why we say that whatever we are seeing on weighing machine is our weight. Why I am saying this is because you will see in the next scenario how this weighing machine weight can be changed. Okay. So if you find yourself as overweight, what do you have to do? That trick I'll tell you. So one is that people say that okay, if you go to moon, then your weight will reduce to 1 by 6. Why? Because the gravitational force on moon is 1 by 6 of that of the earth. So if earth is having what 10 meter per second square as gravitational force, gravity, then moon will have only 10 by 6. So that is equal to 1 point something meter per second square as the gravity over there. So acceleration due to gravity over there. So your mass will not vary, but your weight will vary in different planets depending on the acceleration of gravity. But on Earth, if you want to see the variation of weight, variation of weight of something, of you or your friend, or of any object, then what you have to do? We'll see that. The first is motion of man in a lift. Okay. So think about a lift which is moving upwards with an acceleration of A. So lift is moving upwards with an acceleration A. Okay. So this is the lift moving upwards with acceleration A. A man is standing here, and he's standing on a weighing. Maybe he's a fitness freak. He's standing on a weighing scale always. Okay. So what he is doing is, so what will be the reading of weighing machine? That is what we need to find it out. That means what? What will be the normal reaction of this man exerting on the surface of floor or weighing machine? Okay. Also, what is the normal reaction that this man is exerting on the surface wherever he is standing? That is what we need to find. That is what I am saying as the reading of weighing machine. Okay. So we will take two scenarios. One is observer is standing on, observer is an inertial frame. That means on ground. Okay. Another is observer uh, is in a non-inertial frame, that is lift. Because lift is traveling at the acceleration of A upwards. So that's why this is non-inertial frame and inertial frame. So think about this inertial frame. So how we will be seeing us? So this is the observer who is standing on ground, and this is the lift with acceleration A, and this is the man who is standing on the weighing scale, and this man is exerting a weight mg downwards. So for the person who is standing in inertial frame, it's like net force equal to mass times acceleration. So net force is what? So we know that there is this reaction force uh, from the ground on this man. So FBD of man we have already discussed here. N minus mg will be coming. N is acting upwards, mg is acting downwards. So N minus mg equal to m times A. So N equal to what? Mg plus ma. So that means m equal to g plus m times g plus A is N over here. So normal reaction has varied. That means on the weighing machine, what will happen? So the weight will be increased. So G is on, if acceleration of this lift is 1 meter per second square, then weight of the man will change. Like if the mass of the man is 6 kg and G is 10 and acceleration is 1, so it will be 66 kg. Instead of 60 kg, it will show 66 kg. Okay. And in non-inertial frame, how will you calculate this one? That is when we will be remembering our concept of zero force. Okay. So what will happen is this this is a lift. Okay. This man is standing over here on the weighing machine to calculate the reaction force on the weighing machine. Then observer is also here inside the weighing machine. Sorry, lift. Okay. And this lift is moving upwards with an acceleration of A. So what is happening? This man will see this. The observer will find that man inside the lift to be in a stationary position, because for him he is not moving anywhere. Right? He won't see that because he is also moving along with the passenger. So the relative uh, change in position is always zero. So he won't perceive the motion of the passenger. Okay. So for him, this man is at rest. Okay. So what is happening? This normal reaction is there. Then this weight of the man is there. And this person is at rest. The person who is traveling on the lift, inside the lift. Okay. But Another thing is, whenever you are talking about a non-inertial frame, you will always add something called a pseudo force over here. Okay, pseudo force. How to add that? So this pseudo force will have a magnitude of mass times acceleration of the frame of reference, and it will always it will always act opposite to the direction of the acceleration of frame of reference. Okay, so this MA will be acting downwards. Okay, so that's how you calculate the normal reaction. So how will you calculate the normal reaction? N minus mg minus ma equal to 0, because this person is at rest. That is net force equal to 0. Okay, so n minus mg minus ma equal to 0. N equal to what? M g plus a. So you will be getting the same value in inertial and non-inertial frame. So how did you get the same value? Because you know the concept of pseudo force. Otherwise, for this observer inside the lift, he cannot he cannot explain why this man is having this much weight. So they are like best friends. Okay, so they went to a hospital, and then they got their the vitals checked. So that time he saw that, okay, the weight is 60 kg. Okay, all of a sudden, so this weighing machine, they are somehow they are carrying it with them, and inside the lift, this observer is asking his friend that, okay, can you check your weight? All of a sudden his weight has increased to 66 kg. So this man is like amazed. Okay, he's like, within seconds, how did he increase 6 newton of weight? We will always speak about kgs, right? But this always newton. Whatever you are seeing on the weighing scale, that is weight. Okay, weight is force. Force is in Newton. So this person will be like, how are you increasing this much? By 6 points you have increased. So that explanation comes only when you think about the pseudo force which is acting on their frame of reference. Okay. So this is how we will calculate when the lift is moving upwards with an acceleration of A. Now think about a similar case where lift is moving downwards with an acceleration of A. So this is lift. This is the passenger inside the lift. He is on a weighing machine, and then there is acceleration A that is acting downwards. Okay, so the lift is moving downwards with an acceleration of A. Now what will happen? Inertial frame means ground. Observer is in observer is grounded. Okay. Well, this means observer is in lift. Lift is a very what to say, the slang term. It's actually elevator, right? Anyway, Ottoman has built the first elevator. Huh. So okay, so we were discussing about lift moving downwards with an acceleration of A. So for an inertial frame, what is happening is this. Okay, so for inertial frame, what is happening is, for this man is moving uh, downwards with an acceleration A, and this person has a weight mg acting downwards and n acting upwards. So n equal to so this will be like n minus mg equal to, okay, once. Okay, we will be taking, okay, so this is the, so mg minus n equal to a, because a and mg is having the same direction, right? So mg minus n equal to a, so n equal to m, then a times m. Okay, so this will be g minus a for this person on an inertial frame. Now, on non-inertial frame, what is happening? Again, this observer and the passenger both are on lift, both are inside the lift. So, as the observer, so for him, he will perceive a pseudo force, right? So, what will be the free body diagram of the passenger as seen by this observer is mg is acting downwards, then n is acting upwards, and the pseudo force is acting upwards. Why? Because pseudo force is always acting opposite to the direction of acceleration of the frame. So F pseudo equal to m times a. So how will it happen? mg minus n equal to ma, or you can say mg minus n minus ma equal to 0, because it is at rest. For this observer, this person is at rest. So then n equal to mg minus ma equal to m times g minus a. Okay, so for this person, when lift is moving downwards, what is happening? It feels like the normal reaction force is lesser than what we will experience when you're on a stationary ground. So for this person on weighing scale, the weight will reduce. So why? Because there is this pseudo force which is acting upwards, which is balancing the weight of this person. Okay. So that is the difference between lift moving upwards and lift moving downwards with same acceleration. One is like you will perceive a higher normal reaction when the lift is moving upwards, and another one is when lift is moving downwards. You will feel like, or the observer will perceive a reduction, or there is a decrement in the normal reaction magnitude. Okay. Now, motion of a block along a wedge. This is also a similar case, just like uh, okay, just like the lift. Before that, let me ask you one question. Like this A, if it is equal to G, what will happen to the normal reaction force? A is equal to G. What will happen to the normal reaction force? Normal reaction force becomes 0 if A is equal to G. So what is happening there? Both the objects are free falling. Like the weighing machine is also falling with the acceleration g, and the man is also falling with an acceleration g. Okay, that means it is like there is they are barely touching. Okay? They are barely touching. That this man is not touching the surface of the weighing machine properly. It's not like he's floating on air. But imagine like this. For example, two cars are there. Okay, two two cars are there. Both are moving at the same velocity. Same velocity. V, and this car is also there. It is also moving with the velocity V. And there is a small gap between both of them. It is like as if they have collided and not, or but they haven't collided. There's a very little gap over here. But they will never collide because both are moving at the same velocity. So they will maintain this gap. So it's the same way here. Both are this weighing machine and the person, both of them are not touching each other. So the normal reaction which is experienced on this weighing machine will become 0. Okay. So that is what is the free fall condition is happening. So lift moving at an acceleration g is equal to free fall. Okay. Now, motion of a block along a wedge. So what will happen when a block is placed on a smooth surface of a wedge? We have solved similar kind of problems before. It is like this is a smooth fixed wedge at a angle 37 degree maybe. Okay. And this is a block M here. What will happen is, as you have solved earlier, like this mg will act downwards, and the components of it will be, we can resolve it to show the parallel and vertical components which is acting on the surface of the wedge. So the vertical component will be mg cos 37, and the parallel component will be mg sin 37. So this force is what is accelerating this block downwards. So this mg sin 37 is accelerating this block with an acceleration a. So a is g sin 37 degree. This is what you have learned before, right? Now, what will happen if this block itself is moving with the acceleration a? So what will happen when the block is moving upwards with an acceleration a? Okay, we need to find the acceleration of block with respect to wedge and with respect to uh, ground. Okay, so that is like observer is on the wedge and observer is from the watching from the ground. Okay, observer from ground, observer from wedge. So how will they perceive the acceleration of the block from two different frame of reference? One is, okay, let's take this a to be g. Okay, so this wedge is moving with an acceleration g upwards. Okay, so this observer, whoever is standing on this wedge, will also be moving with an acceleration g upwards, right? This block is also moving with an acceleration g upwards, right? So what will happen is, for this block over here, with respect to wedge, I will draw. So this is the slope. Okay, this is slope. It's the block. It's m. So this is mg acting downwards, and this is mg acting upwards. What will happen is, this component will be like this. Okay, this component is mg cos 37, and this is mg sin 37, and another one is this one mg. Okay, this mg will have a parallel component like this and a perpendicular component like this. Okay, so this is mg cos 37, and this is mg sin 37. So both of this will balance. So horizontally, you'll have the net forces, net force equal to 0. So mg sin 37 and mg sin 37, it will balance. Vertical, what will happen? Vertical also, this will be having net force equal to 0. So the normal force which is acting perpendicular to the surface of this wedge will be equal to 0. This is the same condition as that of what to say, this oh, one second. So what is happening is, okay, I was wrong. So what will you do is, the pseudo force is what we are talking about, right? Pseudo force on the wedge means what is happening. The pseudo force we have to consider. How do we consider pseudo force? That is opposite to the direction of acceleration of frame of reference. So opposite means, again, the pseudo force will also act vertical like this. So mg plus mg, right? So this will also have what? This when resolved will give you again mg sin theta over here, mg sine 37 degree over here, and this will also give mg cos 37 degree over here. And there is this normal reaction, which is like perpendicular to the surface of this wedge. Okay. So what is happening is horizontal will be 2 mg sine 37, and vertical it will be m equal to 2 mg cos 37 degree. That is how you find the reaction forces and the acceleration, the force which is pulling this mass, the block downwards. So what will be the acceleration of this block? Acceleration equal to mass times acceleration equal to 2 mg sine 37 degree. So m and get cancels. So a equal to 2g sine 37 degree. Okay. This is how you calculate the acceleration from wedge. Now, acceleration of block with respect to ground, how will you calculate it? So this is the wedge over here. This is the block. So this is acceleration. So acceleration g is acting upward. So m times g is acting upwards. Then this is like the component of weight which is acting downwards. Okay. What? So this is something like acceleration g. Oh, 1 second. I'll draw it like this. This is acceleration g. This is acceleration of this block initially, that is g sine 37 degree. So we need to find the angle between these two. Okay. How to do this? This is 37 degree. This is 53 degree. This is 180 minus 53 degree. Now we need to find the resultant of this, both of this. Let's using the parallelogram law, right? So how to do that? Resultant R is equal to the root of, so we will take this as A and B. So A is, we can calculate it from here, 2 mg sine 37 degrees. So A is what? 2 times G 10 times 3 by 5 equal to 12 meter per second square. So A is 12 meter per second square, and this is equal to 10 meter per second square. So this is 12 square plus 10 square plus 2ab cos theta. So 2 times A is 12, B is 10, cos theta is 180 minus 53. That will be equal to 144 plus 100 plus 2 times 12 times 10 times minus 3 by 5. It is like cos 180 minus 53 is equal to minus sine 37. That is equal to 244 plus 240 times 3 by 5 is equal to root of 100 equal to 10 meter per second square. So that is the resultant acceleration over here. Okay. What we did here is we have considered the acceleration of this block that is being perceived. So we have calculated the acceleration of this block from wedge. and that is the original acceleration that we feel here also, right, from ground. Then we will also understand that okay, there is this acceleration of this wedge which is being which is going upwards, that is also being seen from the ground. So we will see the resultant of these two acceleration. One is this upward acceleration of this wedge, and the acceleration along the wedge down the slope. We will see this both of this acceleration, and we will perceive the resultant of both of this acceleration. So that resultant is what we have calculated using the parallelogram law. Okay. So this is how we calculate the pseudo force or the acceleration of object on a from an inertial and non-inertial effect. Okay. I hope this section was effective in understanding pseudo force and the types of frame of reference. So that's all for today's class. Thank you and have a great day.